Lesson 7, Creating and Managing a Snapshot Standby Database. After completing this lesson, you should be able to create a Snapshot Standby Database, and also you should be able to convert it back to Physical Standby Database. What is a Snapshot Standby Database? Snapshot Standby Database is a fully updatable standby database. And you can convert physical standby database to make it as a snapshot standby database. Snapshot standby database, you can receive an archive redo coming from primary database. However, a redo cannot be applied because a snapshot standby database is fully updatable. It itself generates redo. And we can use this snapshot standby database for testing purpose. The redo received from a primary database, this will be applied to resynchronize physical standby database when you convert it back to physical standby database. When physical standby database is converted to the snapshot standby database, internally implicit guaranteed restore point is created, and also flashback is implicitly enabled. The purpose is, by doing so, when you convert it back to physical standby database, flashback database technology is used to clean up all the changes made during the snapshot standby database. And then we can apply newly received reader coming from primary database, eventually to resynchronize physical standby database as the snapshot standby database as a physical standby database. So this diagram is giving you good information. When you convert physical standby database to snapshot standby database, and you will see few observations. Number one, MRP process will be stopped, which is a redo apply service, because we're going to make changes to snapshot standby database. Thus, redo apply service cannot apply changes from primary database. Number two, even though your physical standby database is converted to snapshot standby database, redo can be transported to standby database continuously. The benefit is, when you convert it back to physical standby database, since the redo already available in the physical standby side, we can simply resynchronize the converted physical standby database. So let's see how we can convert physical standby database to a snapshot standby database. As we saw from the diagram, we have to stop redo apply service and ensure that your database is in mount state but not open state, and ensure that fast recovery area has been configured, because when you convert it to snapshot standby database, the flashback logs will be generated because we use it to convert it back to physical standby database. And then we're going to issue alter database convert to snapshot standby database. And then we can open physical the snapshot standby database in the read-write mode. Activating a physical standby database in issues and quotients. When activating a snapshot standby database, be aware of a potential data loss with a corrupted log file. It depends on your testing time period. It's a good idea to choose secondary physical standby database as a snapshot standby database. The reason is during the lengthy testing, let's say you had 2 hours in the testing, and then we received the redo, okay, from primary database for 2 hours. And before applying this redo, you have a corrupted log file. And when you convert it back to a physical standby database, it may cause problem, even though you have other options available to synchronize physical standby database. So that's one thing. So in general, it's not best practice to choose the only physical standby database as a snapshot standby database. Instead of that, you better choose secondary physical standby database as a snapshot standby database for testing. And snapshot standby database target restriction. Snapshot standby database cannot be the only standby database in maximum protection configuration. Makes sense. We didn't discuss this topic, but I can give you up to this point. In the maximum protection, if it's not possible to keep synchronize the physical standby database, your primary database will shut down. So that's why your snapshot standby database cannot be the only standby database, because all the time your primary database will down. And it cannot be a target of a switchover. And also, it cannot be a fast start failover target. So it's a good idea to choose secondary physical standby database as a snapshot standby database. So after you convert physical standby database to snapshot standby database, you can verify current database role from $$ database. And $$ database will report database role as a snapshot standby database. And you can also monitor space requirement for snapshot standby database. So we have a flashback log, a flashback database feature implicitly enabled, even though you disabled and you haven't enabled the flashback feature. When you convert it to snapshot standby database, flashback database implicitly enabled. So you will see flashback logs in the fast recovery area. So you have to have enough space. And also you can convert snapshot standby database to a physical standby database. To do so, on a rack database, you have to shut down all of the instances except for one, and ensure that database is mounted but not open. And then we're going to issue alter database convert to physical standby database. What it does is, behind the scene, flashback database is applied, and that must be done in mount state because it is an incomplete recovery. And then redo received from primary database will be applied to resynchronize physical standby database with the primary database. Okay, so we have a quiz here. Snapshot standby database can be created from logical standby database. The answer is no. It's always from physical standby database. Okay, so I briefly covered snapshot standby database. It's a quite simple topic. So what I'm going to do, I'm going to jump into demo environment, and I will show you a couple of demos. And then you will perform hands-on practice activities. Okay, so I'm in the demo environment. In this demo environment, I will show you a couple of things. We have a host 01, that's my primary database location. And we have a host 03, that's my standby location, physical standby location. So what I'm going to do, I'm going to open up another terminal window, which is host 02, to leverage DataGuard Broker command line interface. We didn't discuss DataGuard Broker command line interface, but I will show you, demo through the command line interface, because during the practice time, you will use a SQL command, and you can easily compare to see which one is simpler. So I'm going to use DGMGRL, and I will connect to my primary database. And my current configuration of a DataGuard is this. I have a Boston database, which is a primary, and Boston file sync, and we have a London database. And this configuration is same as your practice environment. So I created a demo environment just to simulate your practice environment. So here we have a London database, that's a physical standby database. Now at this point, let's check a couple of things. I will log in as sysdba, and I'm going to run a script. I created one script here. Oracle setup, check logs. So that's my current sequence number in the primary database. In the standby database, I will log in as a sysdba, and then I'm going to run home Oracle setup check logs. So as you can see, it's the same number. So I'm going to actually switch log file, alter system, switch log file. So on both sides, primary database and standby database, I should have the same number. Now, so my primary and standby database is synchronized. The second thing that I want to check is, in the standby database, I have an MRP background process running. Okay, and then also, let me double check here, show parameter. Before that, show PDBs. As you can see, my database is a read-only mode. My DEP1 pluggable database is a read-only mode. So when you attempt to create a table, I will get error message. So alter session set container equals to DEP1. And let me create one small table. Create table. I will create table in the hr.emp, so HR location, HR schema in the DEP pluggable database, and ID and number, and that's it. So name already used. Okay, does that mean I can just change the name and create table with a new name? So let's double check. As you can see, I got this message. So database or pluggable database open for read-only access. So it doesn't allow me to create a table in the physical standby database. So now what I'm going to do, I'm going to access to DataGuard Broker command line interface, and I will show you one command, help convert. So we have this command, convert database name to Snapshot standby database. When you perform practice activity, and you will use SQL command with several steps. Since there is no practice activity on DGMGRL data guard broker command line interface to convert snapshots to convert physical to snapshot standby database. That's why I'm showing demo here. So let me actually do it this way. Convert database London to snapshot standby, and then hit enter. So as you can see, I just issued one single command, and data guard broker, it does everything for us. And starting from lesson 9 and 10 and 11, we will discuss about data guard broker command line interface. You will see how simple it is when managing data guard configuration. So it takes a little bit of a time. So meanwhile, I will connect to host 03, and then I will double check. I will log in as a sysdba. So it's still hanging because there are just a few things that must be done. So I will wait until this job is done. Since it takes a little bit of a time, I will pause this recording and I will resume my demo. Okay, so after waiting for a while, as you can see, my database becomes the snapshot standby database. Conversion was done. So I can just type show configuration in the data guard broker. As you can see, London database is snapshot standby database. Okay. Now from the SQL prompt, I can just try that. And then when you type select database underscore role from $, database, and it will show you snapshot standby database. That's what we can see. Next thing what we're gonna do here is from the primary database, I can actually the switch logo file a couple of times. The first time, and then second time, and third time. And then I will check current sequence number is 124. Now in the snapshot standby database, when you double check, so it is 120, so it's not archived, so it's still actually available, but not yet available. But later on, this will be catching up. And then what I can do here is I can check MRP background process, pgrep minus lf MRP. As you can see, it was just stopped. And then let's do it this way. I will switch container, alter session set container equals to dep1, and I will create one simple table. So create table data guard 01 ID number, and done. So I can create. I can also insert into data guard 01 values 1, and I can even commit. And also alter, and then I will switch back to root container to switch logo file. So I switch it. So now what? In this location, I can switch to dep1. So I'll alter session set container equals to dep1, and then I will describe data guard 01, nothing. So it doesn't exist. So can I create new table here? So let's take a look at show PDBs. As you can see, since it is a snapshot standby database, dep1 was open read write mode. So I can create table here, create table. So I can create a table data guard 02 and ID and number. and then I can insert into data guard 02 values 1, and I can insert. I can even commit. Perfect. So that's what I can do. However, a table that I created in the primary database, it was invisible in the Snapshot standby database. Now what we're going to do here, we're going to convert it back to physical standby database. So when you type help convert, so you will see that convert database name London to physical standby, and semicolon, hit enter. So as you can see, there are a couple of things that are going on in the background. Converting database London to physical standby database, and operating requires the shutdown of an instance because at mount to state, flashback must be complete to clean up all the changes that were made at Snapshot standby database, and then we're going to apply all the changes that were from the primary database. That's a resynchronization process. So we connected it to London database and database mount, and continue to convert database London. Again, you will do same practice activity but using SQL command. And this is data guard broker command line interface example. Okay, so finally conversion was done. So let me come back to this location. I will exit out because this database was restarted a couple had to restart it to convert it back to physical standby database. So I will log in as a sysdba, and then let's check database role from $v$ database. As you can see now, it's a physical standby database. And then what we're going to do is I will switch container to dep1. Okay, I missed the set alter session set container equals to dep1. And then let me describe data guard 01 now. Look at this. So now it's possible. But what about table created when database was in Snapshot standby database DG02? It's gone because the flashback was done as a part of a converting Snapshot standby database back to physical standby database. So this is a short demonstration. So I briefly introduced what Snapshot standby database is, and also architecture of a Snapshot standby database, and also I showed a short demonstration of a Snapshot standby database. This is lesson 7. Practice 7-1, converting physical standby database to a Snapshot standby database. As you know, physical standby database is not updatable, but Snapshot standby database, it can be open read-write mode, so you can make any changes for testing. So as a part of practice 7-1, we will practice how to convert physical standby database to a Snapshot standby database. The first step is you get into host 03, assuming that you already configured your environment with the ORA EMV and Oracle Seed London. And you're gonna get into SQL Plus, and make sure your current database role is a physical standby database. And in the physical standby database, flashback feature currently turned off. And we will actually enable flashback database feature later on, but not for this practice activity. But when you convert physical standby database to snapshot standby database, the flashback feature will be turned on implicitly. And let's take a look at flashback retention target. The current target is a 1440 minute. And make sure you have enough space to keep flashback log. So we have enough space. Currently, in the fast recovery area, there are different types of files, especially flashback log is 0. So there is no flashback logs in the fast recovery area because we never turned on flashback feature. And then we're going to convert physical standby database to snapshot standby database. Let's see if it works or not. As you can see, you cannot convert physical standby database to snapshot standby database if your redo apply service is active. So what you have to do is you have to cancel redo apply service, meaning that you stop redo apply service. Finally, you can convert physical standby database to snapshot standby database. Now, after you convert, when you check database role, it must be snapshot standby database. So for temporary, this database support any changes to support testing operations. So it is a snapshot standby database. And when you look at flashback feature in this database, we store point only, meaning that your snapshot standby database leverages flashback feature implicitly. So what is the purpose? The purpose is once your testing is done in the snapshot standby database, you should be able to flash back to physical standby database. So in order to convert it back to original state, we use a flashback feature implicitly. So when you look at restore point, the time when you convert it to physical to snapshot standby database, implicitly snapshot was created. Actually, restore point was created. And this is time when your physical standby database was converted to snapshot standby database. Now, what is open mode of a snapshot standby snapshot database? As you can see, it's a mount mode, and also you will see flashback generation. In my case, I have 2 flashback logs. Your output may be different. And when you, if you want to convert it back, let's see if it's possible to convert it back. As you can see, you cannot convert it back to physical standby database. The requirement is once you converted your physical standby database to snapshot standby database, and next you have to open your snapshot standby database in read-write mode. That's a requirement. So we're going to open snapshot standby database in the read-write mode, and you can make any changes for testing. And also, you can switch to dev1 container and make sure you open dev1. And before getting to dev1 container, at the CDB root, you can also open pluggable database. In this case, you got into dev1 container first, and then you're going to open pluggable database in the connected pluggable database. Since your database now Snapshot standby database, and you should be able to perform DML testing operations. So I will create a table and I will make changes. Here we go. I don't have any problem. I can also test and I can commit. I can also roll back. And this I will switch back to CDB root. And then let's get into Boston primary database. I will log in as a sysdba. And then let's check the last sequence number of archive log file. So it's 25. When you switch log file from primary database, it's gotta be 26. In my case, right. So now let's take a look at host 03, your Snapshot standby database. The time when we converted to Snapshot standby database, we stopped redo apply service, which is an MRP background process. So there will be no the recovery of a physical standby database by using redo coming from primary database. However, redo transport service, it works. As you can see, redo continuously transported. But the only thing is, the standby database doesn't apply this change until your Snapshot standby database converted back to physical standby database. So that's one thing what you can see. If this were a real world, you should have more than one physical standby database. So you keep one primary physical standby database to protect your primary database in case of disaster scenario. And if you have more than one physical standby databases, then you can choose secondary standby database. So for testing, you can convert it back to you can convert it to Snapshot standby database. And once your testing is done, you convert it back to physical standby database. During the test, you still keep primary physical standby database. So that way, we can protect database from disaster scenario. In my case, I had only one London database, but demonstration purpose, we just simply converted physical to Snapshot standby database. Again, this is a demonstration purpose. In real world, you shouldn't convert physical standby database to Snapshot if a physical standby database is the only standby database in your environment. That's not recommended. So practice 7-1, it showed how to convert physical standby database to Snapshot standby database for possible testing. That's for practice 7-1. In practice 7-1, we practiced how to convert physical standby database to Snapshot standby database. Now in practice 7-2, we will convert it back to original state, making your database as a physical standby database. So to start this task, you locate terminal window on host 03 and you log in as a sysdba and attempt to convert Snapshot standby database to physical standby database. Alter database, convert to physical standby. As you can see, it doesn't work because the conversion process, it doesn't require mounting your database to perform flashback database feature. So the first step is you will have to shut down London database and then restart up to mount state. So that way we can perform incomplete recovery using flashback database feature. Okay, so I will start up mount. And then I will convert it back to physical standby database. Implicitly, there will be the flashback database feature going on in the background. So when you look at flashback feature in the London database, as you can see, it turned off. And also, there's no more flashback logs in the faster recovery area because we haven't enabled the flashback database feature explicitly. That was only implicit to support Snapshot standby database and to support convert it back to physical standby database. So once you converted it back to physical standby database successfully, and let's open physical standby database read-only mode. And switch to dep 1 and open dep 1 pluggable database. And let's see if a table exists. In the Snapshot standby database, we created one table for testing. What about in the physical standby database? This table already flashed back, as you can see. So the table and changes that you made in the Snapshot standby database, those changes no longer exist because we already flashed back. And there is no data dictionary on the table that was created. We're going to switch back to CDB root. I'm going to shut down database. And I'm going to start up database mount to state, and I will start redo apply service, meaning that I will not enable active with data guard real-time query feature. Okay, so I will start up mount. And then I will start redo apply service. And let's double check. pgrep minus lf mrp. Yes, it's running. However, you cannot query at this state because your database is in mount state. If you want to perform a real-time query, you have to open your database read-only again, and you have to start redo apply service in the read-only mode. And finally, we exit out from the SQL Plus to prepare for the next practice activity. But you keep terminal windows open for the future practice activities. This is for practice 7-2.